guys, it's Mariana, and today we're going to be reviewing some of the 1.3 recursive equations homework for IM2. In this first question, we are giving a data table, and our job is to figure out what type of function it is, whether linear, quadratic, or neither. With a linear function, there will be a first common difference between the data points, versus with a quadratic function, there will be a second common difference between the data points. Now that we know those definitions, we need to figure out if the difference between the data points have a constant first difference or a constant second difference, or neither. From this data table, we can tell that there is a constant first difference of +2. Because there is a constant first difference of +2, we now know that this function is linear. Now that we have figured out that it is a linear function, we need to begin writing our recursive equation. A recursive equation is simply an equation that defines each term of a sequence using the preceding terms. What this common first difference of +2 is technically saying is to get to our next term, we have to add 2 to our previous term, which is where that +2 comes in. That +2 first difference is simply saying whatever our previous term is, if we add 2, we will get our next term. So our final recursive equation will read next term is equal to previous term plus 2. Now, to once again summarize how we got to that recursive equation, we found from the data table that there is a constant first difference of +2. And our recursive equation is simply asking us what plus our previous term will get us to our next term. And we know that since there is a constant difference of +2, whatever our previous term is, if we add 2 to that, it will give us our next term. Now, for the second question, we are going to repeat the same process. We are first going to find the difference between the data points and figure out if there is a constant first difference, constant second difference, or neither. Now, as we can see, there is a common second difference of +2. Since there's a common second difference, this type of function is going to be quadratic. Alrighty, now to write the quadratic recursive equation, I'm starting off with final term is equal to previous term plus the rate of change. So the reason we have a rate of change is because, as you know, quadratics have a linear rate of change. So what I did here is I simply just plugged in some numbers from the data points. I decided to plug in 2. So we know that if our input is 2, our output's going to be 4, which is where I get that 4. And our previous term of 2 is 1. And so we know that if our input is 1, 0 is going to be our output. And now I'm just trying to solve for the slope or the rate of change for this recursive equation. So I'm just going to divide both sides by 2, which will get me to a rate of change of 2, which goes along with our constant second difference of +2. Recursive equation for this quadratic function will be next term is equal to previous term plus 2 of current term. So now we have question 7, and I'm going to start off by trying to find a common difference between the numbers in each figures. I'm going to try to figure out whether it is linear or quadratic. Alright, so it has a common second difference of +3, meaning it is quadratic. And now we need to find some way to solve for this sequence, so we're going to use an explicit formula to solve for it. Alrighty, now we're solving for the explicit formula of this sequence. And so what I like to do to solve for the explicit formula is I like to actually look at the figures themselves and try to find like a pattern somewhat that corresponds with the figure number. So as you can see, for each of them, I blocked out, like I outlined the middle parts per se. And so for figure 1, you can see that section that I blocked out is a 1 by 1. Figure 2 is a 2 by 2, figure 3 is a 3 by 3, and figure 4 is a 4 by 4. So what I'm seeing here is that this is literally just the figure number squared. Okay, now I'm looking for any other patterns that correspond once again with the figure number. And so what I see from each one is that I'm gonna highlight where I actually see these, but in each figure I see that there is 2 of the figure numbers. So for figure 1, at the top we have 1 block, and at the bottom we have 1 block, which corresponds with our figure 1. In figure 2, we have 2 blocks and 2 blocks on the bottom. Figure 3, 3 blocks at the top, 3 blocks at the bottom. Figure 4 has 4 blocks on the top and 4 blocks on the bottom. So that is something that we can see changes between each figure, but the pattern that we see is that whatever value or whatever number the figure number is, that is the same amount of blocks that we are going to have on top and on the bottom. So for that, we can label that as 2n, because we can visually see that there are 2 of each figure numbers each time in the figure. So our current explicit formula reads n squared plus 2n, but we can tell that this is not fully expressing our sequence right here, our figure sequence. So we need to find something like, what exactly are we missing? There's something that we're missing here to make this explicit formula true. And so we're gonna look at what is not like blocked out, what I haven't highlighted, and all we see is that at the end of each figure, there are 2 blocks that remain constant. So what I'm gonna add on is n squared plus 2n plus 2. That is our explicit formula. The reason we added the plus 2 is because those 2 blocks stay constant between all the figures regardless of the figure number. So if I were to try to solve another one of a problem similar to this, my strategy would be to firstly identify any patterns that might correspond with the figure number, and then once I write down those patterns, I want to look at whatever like constant stays the same between each figure to see if maybe there's like a plus 2 or a plus 0 at the end, which represents a constant of like a block that will always be there. Alrighty guys, that is it for the 1.3 homework review. In this video, we reviewed how to write recursive equations for both linear and quadratic functions, and we also worked on creating explicit formulas. Alrighty guys, if you guys have any further questions or anything that you would like some further explanation on, feel free to leave a comment or ask one of your math teachers, or even sign up for tutoring through Alpha Theta, which you can scan a QR code in the library. And don't forget to subscribe to Math Tutoring to Go so you never miss one of our uploads.